Go.
My name is George, and I'm back again. I'm here to talk about the stages of a meteor and a meteorite breakup. Okay, we'll go over here. This is stage one. You have the meteor, which is either a gray color or a white gray color. And maybe it might have the little circles, the little craters on it. Maybe. Now, stage two, the meteor is all black fusion crust. When it enters the mesosphere and it starts to burn up, you get all black fusion crust. Now we'll go down here to stage three. Stage three, and I couldn't put it in all black fusion crust or you wouldn't be able to see the lines. Stage three is solid black fusion crust, and you have flow lines or drip lines that go from front to back, which are these wavy lines. All these different wavy lines go from front to back. They form on the weakest part of the black fusion crust. After the meteor has entered the mesosphere, the lines form after the black fusion crust. It forms in the weakest spots. Now each line gets super hot and penetrates through to the center of the meteor. They all penetrate toward the center of the meteor. Okay, now we'll go over here to the pictures. This picture here is a full-size meteor. It's in stage three. This picture here is stage 3 too. This one and this one. Now the reason why the color on it, we'll go up here to this one. The reason why the color on it is orange, it's because I dug this out of the ground. It was buried for years in the ground. Now, as you can see here, we'll go down to this picture. What you want to call drip lines, flow lines, or whatever, as these lines right here, they run from front to back. It's still got just a small speck of the old black fusion crust on it. But the reason why it changed like an orangish brown is because it was in the ground and it was pretty well preserved because it was clay ground. Now you go up here to this picture. Closer. Okay. Now you see the white line across there? And there's another one there. And there's one up here. All those lines, these white lines, they get extremely hot. And they penetrate down toward the center. Now here's a piece. Oh, by the way, this is off the Mary Jane I have on TikTok. You can look it up. Now, this piece right here came off of it. It broke off the back part of the meteor. This is the fusion crust. This underlayer, white grayish color, is the layer on the outside of the rock. Now, now this one has a rim on it. Not all meteors have rims. Some of them do, some of them don't. Some of them just start to burn and they burn into the metals and the minerals. This one so happens to have a rim on it because it didn't burn very long in the mesosphere like it was supposed to burn. Now, this little line running across here is your drip line. It runs down here through the rock. It's hard to see it on here, but it's somewhat discolored. And then you follow it around and it comes around here and then it goes back around here. Okay, these white lines right here get really super hot and they penetrate through. All right, now we go over here to stage 4. Stage 4, this is when you end up with the bits and pieces and fragments. The lines converge toward the center, and what point the lines hit molten metal and minerals is when it breaks up. Now, all meteors travel at different speeds. They don't all travel at the same speed. Meteors travel at different speeds. All meteors are composed of different metals and minerals. How big a meteorite is going to be is based on what metals, minerals, how much of each one, and the melting temperatures of the metals and the minerals. Molten metal explodes when coming into contact with water, moisture, or very cold rock. Now, they say that the space rock in space it can be minus 455 degrees. Okay, that's extremely cold. So when it enters the mesosphere, that's going to take a considerable amount of time to warm up. The mesosphere is only like 50 miles across. And at the speed that it travels, if it's traveling super fast, it's not in there very long. It's sort of like when you take your frozen meat and you stick it in a microwave and you defrost the meat. It takes a little bit. Well, the inside of a meteor takes a lot longer to be able to thaw out. And when it's melting in the mesosphere, it's still super cold inside. Okay, in 2013, the meteor over Russia was large and it contained a lot of molten metal. This is why the explosion was so loud and so big. And the reason why I know this, I worked in an aluminum plant. And when the molten metal aluminum comes in contact with, it came in contact with cold tools or it came in contact with water, it would explode. And it depends on the amount that it comes in contact with. The more moisture or the more water that molten metal comes in contact with, the bigger explosion you get. If, when a meteor is flying through the air, it penetrates if the cold air penetrates through the flow lines or the drip lines, whatever people want to call them, okay, it will cause the rock to break up. And if it hits molten metal, it'll cause it to explode. Now, February 15 of 2013 in Russia was cold. So even coming out of the mesosphere, it was warm. But coming down and coming down and coming down closer to Earth, the cold air up there could have penetrated the inside and hit the molten metal, causing it to explode and causing a lot of people to get hurt and a lot of buildings to get damaged. And they're really lucky that it didn't hit the ground or it didn't hit water. Anyways, this will conclude this session on meteors, and how they break up and become meteorites.